The advanced imaging pipeline of the OM system OM-1 delivers excellent dynamic range, which is sufficient for most photographic scenarios. Nonetheless, certain scenes with very high contrast are just too much to handle for any digital camera, including the OM-1. Thankfully, the OM-1 has a powerful array of features to effortlessly capture the full dynamic range of any scene and to create high-quality tone-mapped HDR images in camera. My name is Thomas Eisl. I'm a professional photographer from Vienna, Austria. High dynamic range photography is a controversial topic. Usually, it is associated with strange, painterly abominations commonly known as HDR photographs. In reality, however, HDR photography is a necessity, as the dynamic range any digital camera can record is limited to a certain degree. In this expert guide, I will explain the fundamentals of HDR photography and how to master them with the OM system OM-1 to overcome any dynamic range limitations you might encounter. I can't wait to get started, as HDR photography is not only a very interesting topic, but also a necessary skill for every photographer to have in their repertoire. The term high dynamic range photography refers to the process of capturing a wide dynamic range and subsequently reproducing it with a dynamic range limited medium like a print or a display device. Both tasks, capturing and reproducing high dynamic range scenes, are equally challenging. If the dynamic range of a scene exceeds the capabilities of the digital camera, tonal values are no longer reproduced, resulting in clipped highlights and/or clipped shadows. Then the scene has to be captured with multiple photographs, each using different exposure settings. The resulting images have to be combined using either tone mapping or exposure blending. Tone mapping is a collective term for various image processing techniques which approximate the appearance of high dynamic range scenes in a medium with limited dynamic range. Usually, tone mapping is done on the computer after the shoot. Tone mapping operators can be divided into two categories, global and local. Global operators are usually easier to handle but tend to output low contrast images. Local operators are more sophisticated and in practice often preferable. The downside is that if used incorrectly, the images can assume the undesirable HDR look. Exposure blending is the process of blending multiple exposures to create a high dynamic range photograph. In digital post-processing, this is usually done by layering the captured photographs. Masking or blend modes are then used to create a single photograph, which represents a wide dynamic range. To conclude, in general, the greater the difference between the captured dynamic range and the reproducible dynamic range, the more difficult it is to achieve an end result that is perceived as true to life. The reason is quite obvious. The more we have to compress the dynamic range, the more problematic. Common problems are a loss of contrast or exceedingly artificial local tonal compression. Such images are commonly derided as having an HDR look, If done properly, however, HDR photography will look natural and mimic human perception. When dealing with a high dynamic range scene, the OM-1 offers 3 options to capture its full dynamic range: single exposure HDR, HDR modes 1 and 2, and HDR bracketing. Each one of these has its specific use case. Ideally, the full dynamic range of the scene can be captured with one shot. The dynamic range the OM-1 can record with single exposure depends on the ISO setting and the photography mode. For example, Live ND and high-res shot increase the dynamic range. Of course, they are technically not single exposures. In separate videos and articles I explain these modes in detail, links in the description. The file format, meaning JPEG or RAW, impacts the usability of the captured dynamic range. Theoretically, the 12-bit lossless compressed RAW can store the equivalent of 12 stops with linear encoding. However, all in-camera renderings are 8-bit previews based on the JPEG settings. But worry not, there is a way to set up the OM-1 to display almost the full dynamic range recorded in the RAW file. I will configure the custom picture mode of the OM system OM-1 to display the full dynamic range the camera can capture with one shot. Here is how to do that. Let's bring up the Super Control panel and select the custom picture mode. The custom picture mode is always based on a regular picture mode. And for a flat preview, we have to select the muted picture mode. You can already notice that the preview now displays a wider range of tonal values, but we can improve that even further. Let's bring up the Super Control panel again and configure the subsettings. In this case, we have to reduce the contrast by -2 to get an even wider range of tonal values in our 8-bit preview. But there is an important additional setting that will help us to visualize the full dynamic range stored in the 12-bit RAW file, and that is gradation. By setting gradation to auto or shadow adjust, the OM-1 will pull as much tonal information as possible from the shadows into the preview. So when you expose for the highlights with shadow adjust turned on and all the previous settings are just illustrated, you will see 99% of the dynamic range the OM system OM-1 can capture with one shot. So let's take the shot, and what we see here is that we just captured not only the full dynamic range but also got a natural looking image as a result. With the computational modes HDR1 and HDR2, the OM-1 creates a tone-mapped JPEG file in camera by combining multiple exposures, significantly expanding the dynamic range. To enable either HDR1 or HDR2, there are 2 possibilities. The first option is navigate to the menu and select Camera Menu 2, Submenu 1 Computational Modes, and there you find the option HDR. By selecting that, you can activate either HDR1 or HDR2. But there is a better option to select HDR1 and HDR2 in the field, and that is by mapping the function to a function button. In my case, I've mapped it to the record button, and when I hold down the record button and turn either the front or rear control dial, the HDR menu comes up. Those are the same settings that I can access via the menu. And there I can just select HDR1 or HDR2. The 2 modes have some technical details in common. Both capture a 4-image bracketed burst. The images are automatically aligned and tone mapped in camera almost instantaneously into a single image. HDR1 and 2 utilize electronic shutter only with a 4-second slow shutter speed limit. The ISO setting is fixed at 200. The picture mode is set to natural and cannot be changed. No subsettings like contrast and saturation are available. It is important to know that the processing of the recorded tonal values is non-linear. The black, white and gray points are shifted. RAW capture is optional. When enabled, the OM-1 will store a regular non-HDR RAW file, which is underexposed by 0.5 EV. Note that the RAW file cannot be used to recreate the tone-mapped JPEGs. It is just intended as an emergency backup. Therefore, do not delete the captured JPEGs later. Moving objects in the frame are blurred, much like during a long exposure. If a portrait subject remains reasonably still, HDR1 and HDR2 can be used to expand the dynamic range. This can be very handy in backlit situations. HDR1 will give a natural result with a moderately expanded dynamic range of +1 EV in the highlights. The midtones are only slightly compressed. The compression in the shadows is insignificant. To get a good result with HDR1, correct exposure metering is key. In a scene with bright highlights, utilize the in-camera spot meter to evaluate either the midtones or the highlights. Preferably, I meter the highlights with spot highlight. An exposure compensation of up to +1 EV can be applied to maintain the white point. Alternatively, I could also meter for the midtones using the regular 12.5% spot meter and apply no exposure compensation. If I were to meter the shadows, I would utilize spot shadow with no exposure compensation. HDR2 greatly expands the dynamic range in the shadows. This computational mode most likely applies an advanced local tone mapping operator to achieve that. In the highlights, only insignificant compression is observable. The midtones are slightly compressed. However, the shadows exhibit 2 full stops of compression. This is quite impressive, but be warned. If HDR2 is utilized for a low dynamic range scene, or if you do not meter correctly, the resulting image will exhibit the undesirable HDR look. Here is how to make HDR2 work. For a scene with very bright areas, meter to prevent highlight clipping. For all other scenes, either meter the midtones or the shadows. Preferably, when utilizing HDR2, I meter for the shadows with spot shadow. To maintain the black point, exposure compensation of up to -2 can be applied. If I would meter for the midtones, I would use the regular spot meter function with no exposure compensation applied. When metering for the highlights, I recommend using spot highlight without any exposure compensation. To capture a series of exposure bracketed images for tone mapping or exposure blending in post-production, the OM-1 offers a set of bracketing options. Although HDR1 and HDR2 are very powerful, for most professional applications, HDR bracketing is the #1 choice, as it gives you more flexibility to adjust things in post. Selecting HDR bracketing works just like selecting HDR1 and 2, So let's go to the menu, Camera 2 and their computational modes. Down there just select HDR. You will find all bracketing options just there in the menu. Of course, if you have mapped HDR to a function button, you can just press and hold it and turn the front or rear control dial and select all the same bracketing options. Keep in mind that the function button also acts as a toggle to turn HDR on or off. Let me show you that. Now it's off and now it's on. You can see the little notification in the top left corner of the live view image. Some important technical details. HDR bracketing always uses the vibration-free electronic shutter. Bracketing step sizes are either 2 or 3 EV. Regarding file formats, JPEG and/or RAW are selectable. It is crucial to know that the shooting mode determines whether the camera either changes the aperture setting or the shutter speed to alter the exposure from frame to frame. In S mode, the aperture setting varies from shot to shot, while in A, P and M mode, the shutter speed changes. One more thing, if ISO is set to auto, under certain circumstances the OM-1 will change the ISO setting to bracket the exposures. The main problem photographers experience with HDR bracketing is that it can be difficult to determine the correct bracketing setting and matching shutter speed. The consequence? Guesstimation, which leads to low quality, undesirable results. That is why I developed the following method to determine the correct exposure and bracketing settings for any given scene. For this workflow I utilize my OM system OM-1 HDR Quick Reference. You can download it via the link below. Okay, let's get started. First, we have to set the exposure parameters. And I want to photograph this scene with an aperture value of 5.6 and I want to set the ISO to 200. Although the OM-1 delivers the widest dynamic range at ISO 200, the LED on the right hand side is just too much for the camera to handle. So we have to resort to HDR photography. For metering the scene, I've set the OM-1 to aperture priority mode and I've enabled the in-camera spot meter. I will now move the spot meter together with the focus point over the LED light source to get a meter reading of this part of the image. And the camera tells me 1/4000 of a second. What I'm gonna do now is I'm gonna note this value on my HDR Quick Reference. Now I have to get a meter reading of the darkest part of the image, and this should be probably around here. There we get 1/4 of a second. Let's take a second reading just to make sure around here, and we also get 1/4 of a second. So that's the meter reading for the shadows in this case. Again, I'm gonna mark the metered value on my HDR Quick Reference. With those two meter readings, we can now easily determine the full dynamic range of the scene. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 stops. This scene has a dynamic range of 10 stops. With this information, we can calculate the dynamic range expansion needed to fully capture the whole dynamic range of the scene. In our case, it is 10 minus 4. That is, of course, 6. So we need a dynamic range expansion of 6 stops. The table on the right hand side shows the different HDR bracketing settings, and over there you can see how many stops of dynamic range expansion you get with each one of these settings. So we need plus 6 EV, so that's this setting over here. A step size of 3 exposure values and a bracketing burst of 3 images. Now let's select the calculated bracketing option by holding down the assigned function button and rotating the rear or front dial, and there we go. From now on, we will continue working with the OM-1 set to manual. As a last step, we have to set the median shutter speed value. Again, with the quick reference, this is very easy to do. So as we determined earlier, the total dynamic range of the scene is 10 stops. That's half that, that's 5 stops, and now we just have to count 1, 2, 3, 4, 5. And there is our median shutter speed. Let's dial that in. Now we just have to set the desired focus point, focus the shot, and capture the images. So to conclude, the precise, controlled workflow in the field allowed me to capture the full dynamic range of the scene and create a perfectly natural looking high dynamic range image later on the computer. With guesstimation, this is not possible. Let me finish this chapter with a bonus tip for HDR photography. As you just saw, I set the EV step size to full stops. In practice, this is more straightforward, and thanks to the high dynamic range of the OM-1, this loss of precise exposure control does not have a noticeable impact in terms of image quality when it comes to HDR composites. In the last chapter, I'd like to share some recommendations based on my experiences with HDR photography. Let's start with the most important recommendation first. Do not utilize any HDR technique if the dynamic range of a scene can be captured with one exposure. Because if you do, the tone mapping process will inevitably lead to an unnatural result of low fidelity. So always evaluate the scene first and determine if HDR is truly needed. Regarding camera settings, I recommend exercising manual control over all relevant shooting settings. This means setting the shooting mode to manual, using a fixed ISO value, and setting the white balance manually. Also, always capture RAW and JPEG. More on that later. Even the OM-1's manual recommends using a tripod for HDR photography, because the more stable the camera, the better. If no tripod is available, activate handheld assist and capture multiple series. Pick the sharpest and best aligned images out of the bunch to create the final composite. Although it depends a bit on the HDR software used and the desired result, merging out of camera or processed JPEGs is usually preferable over merging RAW files, to name only a few advantages. First and foremost, if the image is part of a larger series, the color and tonal response are preserved so that the tone-mapped image will match the look of the other non-HDR images. Second, noise reduction and lens corrections will be applied. And third, less computing power is required. I strongly encourage you to try HDR photography with the OM-1. Not only will you be able to overcome any limitations of digital photography in terms of dynamic range, but you will also create stunning work in the process. Mastering HDR photography means mastering dynamic range. If you want to learn all about dynamic range in photography, please refer to my video, Dynamic Range in Photography, a New Perspective. Thank you very much for watching. Please consider subscribing and following me on other social media. See you next time.